All right, so this is one of the word problems that you're going to come across when you're dealing with related rates. So remember those 3 questions that I set up in the last video? What are you looking for? What do you know? And what's the connection? Okay, so what are you looking for? What do you know? And what's the connection? So the first thing we want to do is we want to look for what is the thing that we're looking for? So if we look through it, we read through it, company manufactures radios, the cost is 5,000 plus 2x, and the revenue is 10x minus 0.0001x squared, where production output is x radios. If the production increases at the rate of 500 radios per week when production is 2,000 radios, find the rate of increase in cost. Okay, so we just answered the first question. What are we looking for? We are finding the rate of increase of cost. So we are looking for d, the derivative of cost in terms of time. So remember, related rates is always in terms of time. So how do I know it's dc dt? Because I'm looking for the rate of increase of cost. So remember, a rate is a derivative. Derivative of cost in terms of time. That's what we're finding. The second thing is, what do we know? What information do we have? So this is where you have to go back and you have to identify what do the things mean. So I kind of highlighted it. The production output is X radios. So we know X is the number of radios. So how many radios do we have? We have 2,000. So we know our X value is going to be 2,000. What else do we know? Well, we know that the production increases at a rate of 500 radios per week. So we know that it's a rate, so we know it's a derivative. So the derivative of the radios in terms of time is 500. Okay, so where do I get that? 500 radios, that's what's increasing, that's the rate. So anytime you see the word rate, you know it's going to be a derivative. So it's the derivative of the radios in terms of time. This is the derivative of the cost in terms of time. The rate of increase of cost, rate of increase of the radios per week. Okay, so this is what we're looking for. This is what we know. So now the third question is, what's the connection? Well, the connection is our cost function. Okay, that's the connection. That's what we're going to find the derivative of. So here we go. So I'm going to rewrite this so that the functional notation doesn't throw you. So I'm just going to write it as cost equals 5,000 plus 2x. So we are going to find the derivative. Find the derivative in terms of time of the cost. And then I'm going to find the derivative in terms of time of 5,000. And then the derivative in terms of time of 2x. So I'm just using my cost function. That's all I'm using. Derivative of cost in terms of time, derivative of 5,000 in terms of time, derivative of 2x in terms of time. Here's my implicit differentiation. Derivative of cost in terms of time is dc dt. Derivative of a constant, the 5,000 in terms of time, is 0. Derivative of 2x is 2. Okay, so do you see that? I just used my power rule. A derivative of 2x is 2, and then dx dt. Okay. We're finding dc dt. It's already by itself. I know what dx dt is, so I can find dc dt equals 2 times dx dt was 500. So the increase in cost in terms of time is 1,000. That's what the cost is going to increase by $1,000 when we have 2,000 radios to produce. Okay? Now, I'm going to change this up just a little bit. And all I'm doing is I'm changing the question that I'm asking. Okay? So now, find the rate of increase in terms of revenue. Okay? So now I've just changed the question. So now, what are we looking for? We're looking for the rate of increase in terms of revenue. So we're looking for DRDT. So the change in revenue, or the rate of revenue in terms of time. Our X value, the number of radios, is still 2,000. The DXDT, the rate that the production increases, is still 500. But now, what's the connection? The connection is my revenue function. That's the connection. That's what we're going to use implicit differentiation on. All right, so here we go. So the derivative of revenue in terms of time, derivative in terms of time of 10x, and then the derivative in terms of time of 0.0001 x squared. Okay, so implicit differentiation. dr, the derivative of rate in terms of time is dr dt. The derivative of 10x in terms of time, the derivative of 10x is 10, and then dx dt. The derivative of 0.0001 x squared is 0.0002x, and then dx dt. Okay. Now we're going to plug in our values. The dr dt is what we're looking for. I'm going to, just to save time, I'm going to take my dx dt and plug in 500. I'm going to take out my x and my dx dt. My x was 2,000. dx dt was 500. And now it's a calculation. The dr dt is already by itself. So the rate that the revenue changes in terms of time is, let me get down here, is 3,000. When you multiply this all out, it ends up being 3,000. Okay? So the revenue changes, the rate of the revenue increases at a rate of $3,000 when there's 2,000 radios produced. Okay? So as a business owner, this is important. How is our revenue changing? Is it increasing? Is it decreasing when we're producing 2,000 radios? And now the last one is, I'm going to change it one more time. Now we're going to look for profit. So remember at the very beginning, we talked about profit, revenue, cost. So remember, profit is the revenue. So in terms of profit, I'm going to finish my question here. Okay, so in order to find what the connection is, we have to take the revenue and we have to subtract off the cost, which will give us our profit. So our revenue is 10x minus 0.0001 x squared minus the cost function. So we have 10x minus 2x, so we have 8x minus 0.0001 x squared minus 5,000. There's your profit function. Okay, so here we go again. We're going to find the derivative in terms of time of our profit. And I'm just going to rearrange this. The derivative in terms of time of a negative 0.0001 x squared plus the derivative in terms of time of 8x minus the derivative in terms of time of 5,000. Okay, so all I did is I'm putting it in descending order. So the negative 0.0001 x squared is first, and then 8x is second, and then minus 5,000 is third. Okay, implicit differentiation. Derivative of profit in terms of time is dp dt. the derivative of 0.0001x squared in terms of time. So we find the derivative of this is a negative 0.0002x, and then dx dt, plus derivative of 8x is 8, and then dx dt. And then the derivative of 5,000 is just 0. Okay? So our dp dt, that's what we're looking for. Sorry, I didn't change this. We're looking for the derivative, or how the profit is changing in terms of time. It's already set to equal each other, or it's already set in the correct position. So dp dt is already by itself. Now I'm going to plug in my values. So I have negative 0.0002 times 2,000 times 500 plus 8 times 500. And when I do all of that together, I end up with a profit. So dp dt of 2,000 in profit. So my profit increases at a rate of $2,000 when I produce 2,000 radios. And the rate that the production increases is 500 radios per week. So what we just did is we just combined implicit differentiation with finding related rates, how things are related. And that's it.